on day 3 of Algebra 1. We are still in the first unit, and it is Wednesday, March 26th. So yesterday, we got up to multi-step equations, and we started talking about solving equations like this, where we have variables on both sides. So let's look at these do now problems that you guys have been working on. And we will start with number 1. What are some answers we got for number 1?
12.
12. We got x equals 12. Did anybody get something different than x equals 12? Okay. Well, let's see. Let's see if we get 12. What could I do first here? There's a few options.
Subtract 2x from both sides.
Sure, let's do that. Let's get our like terms together, and by doing that, we need to remove it from one side and bring it to the other. So we'll subtract 2x from both sides. And what happens from there?
2's canceled.
2x's are canceled.
And then it's 6.
Miss Taylor, the
I think
screen's still
Oh,
frozen.
it's still frozen. Thank you. Sorry, guys. I thought you could see what I was doing. Come on. There we go. All right, thank you. I appreciate it. Sometimes I don't notice. Okay, so we subtracted 2x from both sides. My 2x is canceled. And what happens next?
Bring down the.
You solved it.
Bring that, yeah.
It's
Solve
1x.
it first. I'm sorry.
1x.
Okay, yeah, so 3x minus 2x is 1x. We could also just write x, because 1x just means that there's one. So we'll just write next. So what should I do next?
Bring the rest of your problems down.
Let's bring the rest down. I still have minus 5 equals 7. What should we do next?
Add 5 on each side.
Add 5 on both sides. And my 5's will cancel, giving me x equals 12. Good. We got that one right. Awesome.
All right.
Now, I noticed on some of your work as I was kind of peeking around, some of you, when you did the 3x minus 2x, if you chose to do it this way, maybe you wrote 1x.
Mm-hmm.
So you ended up with 1x equals 12. And then you decided, well, let's get rid of the 1. We'll divide both sides by 1.
That's what I did.
Right. And then you get x equals 12. Now, this is absolutely fine. You can do it this way, but do we really need to? If you ever get an answer that says 1x equals something, when you divide by 1, the number does not change. So if you ever get that 1x, you know, I have only 1x. X is by itself. You don't technically need. Yeah, you just wrote 12 2 times. Just took up more space on your paper. You don't necessarily need to do that step. However, if it makes you feel more at ease, it's fine. It's right. So I'm okay with it. But save yourself a little space and you can be done quicker. All right. Any questions about number 1? Okay, let's look at number 2 then. Give me some answers for number 2. What did we get for x?
-1.
-1. Did I hear 8 also?
I got 3 somehow.
3. So we got x equals -1. We got a 3. Did anyone get something other than -1 or 3? 9. Okay, so -1, 3, 9. Any other answers? Or did everyone get one of these 3 numbers?
7.
7? Okay, let's try it. Let's do it.
You got 7.
All right.
I don't know because I got stuck in the middle of the process.
Hey, and that's okay. Let's work it out together slowly. We'll figure out what went wrong, what went right, and we'll go from there.
Well, I got 12 on one side. I did it twice.
You did it
12
twice.
and 7. I don't know.
Okay. Well, let's see. We'll
Okay.
see. What could we do first?
Subtract 2 from 4 and 2 from 2.
Sure, let's do that. The 2x, is that what you're talking about? Okay, so let's get rid of 2x. We'll do minus 2x and minus 2x. Now, we need to be careful when we are subtracting from a negative number. That's easy to mess that up. So I have negative 4x minus 2x. That's the same thing as negative 4 plus negative 2, which is what?
Negative 6x.
Negative 6x.
That's where I'm messing up.
Yeah, that gets us. Whenever we have negatives and it gets us sometimes. Now, remember, it's never a bad idea to check on your calculator if you're not totally sure. But when you have a negative number and another negative number, when you put them together, you're going to get a bigger negative number. Subtracting is the same thing as adding a negative. They are the same
I
thing.
don't know why I keep forgetting that stuff.
Hey, it's all right. We're still getting back into
So
the
we got 6, negative 6x.
Yes. So 6 minus 6x equals
12.
12. All right.
Now you want to divide the 6 from the 12.
Can I divide yet?
No, add the 6 to the 12.
Okay, so add which?
The 6x.
Add 6x? Okay, sure. So just to make it positive, we could do it that way. Why not? What does that do to our equation?
Yeah. Mark out the 6x.
Okay.
And 6.
So now we have 6 equals 6x plus 12. We just moved it over.
Gotcha.
Or you could do 12 plus 6x. We just moved it. There are about 1 million ways to solve every equation. You might not have done it this way. You might not have done it a different way that I show you. There are so many ways to do it. The main goal here, though, is to keep doing the same thing on both sides. As long as you keep it
Basically, you wrote the
equal.
same problem twice.
Kind
Oh, no, you
of,
didn't.
yeah.
Yeah. Just
So
go backwards.
what should I do from here?
Subtract the 12.
Yeah, let's subtract 12.
Okay, from both sides.
I'm gonna have to rewrite over here. So
Looks like two.
let's see, my 12s will cancel. What is 6 minus 12?
Negative 6.
Negative 6 equals
6x.
6x. Now what do we do?
You divide it.
Divide by 6.
Divide by 6.
Then you get 0.
Well, let's see. What is negative 6 divided by positive 6?
Negative 1.
Negative 1 equals x. If it was negative
Okay.
6 plus 6, it would be 0. But we're dividing. So our answer is x equals negative 1. There are lots of ways we could have solved this. There's lots of ways we could have solved any of these. Does anyone have any questions about anything that we just did here? Okay. If you didn't get negative 1, does it make sense why the answer is negative 1 now? Okay, good.
No.
I'm gonna tell you what's wrong.
Mm-hmm.
This is what I know this is what my problem is. That negative, I'm thinking it's just a
Subtraction.
A
subtraction.
subtraction.
Yeah.
Well, and you can think of it as subtraction. Are you talking about right here at this first step
Yeah.
where you
Yeah.
subtract
6
2x?
minus 4?
Yeah.
Yeah, so negative 4 minus 2 is still negative 6. It is just a little bit tricky sometimes to remember that we need to include that sign to the left over here, that it is a negative 4. Did you do 4 minus 2? I get you, and I bet you're not the only one. It's where we can get messed up is remembering that anytime we are putting numbers together, we got to look at whatever sign is to the left of it.
Okay.
So it won't be 4 minus 2, it'll be negative 4
Okay.
minus 2. And if I am already, taking it back to pre-algebra for a second, if I'm already at
What I should have did.
negative 4 and I take 2 away, I'm moving to the left to subtract 1, 2. And as I move to the left, negative numbers get bigger. Negative 4, negative 5, negative 6. There we go. And I appreciate you guys speaking up when you're not sure about something. It really helps me as a teacher and it helps your classmates. Okay. Any other questions about number 2? Let's look at number 3 then. Number 3, what would be a good first step here? Yeah, in general, I don't like to work with a negative x. Anytime I see that one of the x's is being subtracted, I'm going to automatically add that one. So let's add 5x to both sides. Now, doing it this way might have saved you some trouble on the previous problem. If you maybe added 4x to both sides instead, then you wouldn't have had to deal with negative numbers. So that's always an option. Okay, so my 5x's will cancel. What happens next?
Right.
Good. So I have 10 equals 10x minus 20. Okay. 10 equals 10x minus 20.
You can add 20 on each side.
Let's do it. Add 20 to each side.
Your 20 is canceled.
20s will cancel.
10 plus 20 is 30.
Good. 10 plus 20 is 30.
Equals 10x.
Equals 10x. Good. And I'm going to go ahead and rewrite this because I am out of room.
Then you divide by 10.
So we'll divide by 10 to get x by itself. And
30 divided by 10 is 3.
perfect. 3 equals x. X equals 3. That is number 3 for you. Did anyone get something different than 3?
Is x equal 3. Equal 3.
You got 3 also?
Yeah.
Good.
But
Perfect. Let's see. See. Okay, so you added 5. So you did your work a little bit differently than we did, but you did still get the right answer. So there are so many different ways that you can solve it, and it looks like you did it really well. Perfect. Okay. Any questions on number 3? You ready for 4?
Yeah.
Let's do it. Okay. 7x minus 10 equals 4x plus 5. What's a good first step?
Subtract negative 4x.
Yeah, we've got 4x and 7x. A good rule of thumb is let's subtract the smaller one. That's going to keep our numbers positive again. Minus 4x minus 4x. And let's see. What happens here?
Your 4's canceled.
My 4's will cancel. And
3x.
that will be 3x. Good. Bring everything down. Minus 10 equals.
You add 10 on each side.
Add 10 to both sides.
The 10's canceled.
10's cancel.
3x equals 15.
3x equals 15.
Then you divide by 3.
Perfect. Divide by 3. And we'll get
3.
x equals 5. Perfect. All right. That is all 4 of our do now problems. Do we have any questions about any of this? Okay. So I'll leave this up for a minute while I see some of us still copying notes down. And let's go ahead and get our notebooks out. And we are going to take some notes today and learn something new. So I'll title my page off screen so y'all can still see this. And if this process is still feeling not quite comfortable, if it's still feeling a little tricky, don't be worried about us moving on to a new topic because this new topic is still kind of the same thing. You'll still be doing practice with this. There's just some slight differences. So, all right, here, page 1. This will be our day 3 notes. Six. Okay. Can I move this to now, or is anyone still needing it? Go ahead and move that. Now, for the last 2 days, we have been reviewing all the different types of equations that we can solve. But today, and again, if you just took free algebra, you'll recognize this. Today, we're moving on to something slightly different called an inequality. Yes. This might be super familiar if you just took pre-algebra. So, inequalities. We've been working with equations, which, as we kind of defined together, an equation is that number sentence with an equal sign, where whatever is on each side of that equal sign has the same value. They're equal. And inequality is kind of the opposite. We're not looking at equal values anymore. We're still going to do the same process to solve an inequality as we would an equation. It's the same. But now we just have some different symbols. So I want to show you those symbols and name them. Our first symbol looks like this. Does anybody know what this is called?
Greater than.
Greater than. Our next symbol is very similar. There's a line under it now. What's this mean?
Equal to.
Greater than or equal to. Yes. So now we have greater than. Or equal to. And now you were saying that the next set of symbols less than or less than or equal to. So I probably didn't need to take up a whole page showing you these, but
It works.
it works. I already did it. Less than or equal to. These are the 4 symbols that we are going to be using when we solve inequalities. Now, hopefully you left a little space to the side of these words. If you didn't, I'm so sorry. I should have mentioned that. We're going to draw little baby pictures next to each one of them. And we're going to start by just making a line with arrows on either end beside all 4 of these. And we're gonna start moving into the process of graphing. Now, inequalities are the first step at graphing, and we're gonna be graphing on more of a one-dimensional scale. You're only going left or right. There's one dimension there. We get to 2 dimensions whenever we start graphing on an X and Y axis, which we're not doing just yet, but we'll get there soon. So we're going to talk about how to graph an inequality on a number line. So if, for example, I have an inequality that says X is greater than 1, does anybody remember how to graph that? Yes, Michelle, how do we do it?
You're going to put 1 in the middle
Mm-hmm.
circle. You're gonna circle something in there, and then you're gonna shade from the right.
Yes. So what we do is we circle the number that we're referring to, 1. We're saying that X is bigger than 1. So I'm going to circle that, and I'm going to shade in the direction that my arrow tells me to. So because it is greater than, it's bigger than 1, the right side of a number line is where the numbers get bigger. We're in the positives. The left side is where the numbers get smaller. So we're shading all of the numbers that are bigger than 1. This shading actually represents all the numbers that X can be. So for example, I can pick any number that is bigger than 1. Give me a random number. 12. So if I put 12 is greater than 1, is that true?
Yes.
It is true. Yes. It is true because 12 is included in this shaded area. Any number bigger than 1 will be included. Perfect. Can I choose 1 for X?
No,
Why?
it's too small.
That's not-
If it's not bigger than 1. 1 is not bigger than 1. It's equal to 1. So that's why we don't shade in 1. We leave it open to show that it's not included.
Well, and
Yeah.
that's the difference though between the greater than and the greater than equal to.
Yes.
Yeah.
Exactly.
That tripped me up when I was in pre-algebra. I had to like go
Right,
over that.
right. And you know what? You are not alone in that struggle. It is tricky to catch on to. So let's talk about then, what if I had X is greater than or equal to 1?
You shade the area,
Our graph's gonna look almost identical. Let me just go ahead and draw the same graph.
but you gonna color in the circle.
Yes, this time we color the circle in. Because why?
This is equal to or less than.
It is now including 1. It can be greater than 1, so it can be any of these numbers bigger, but it can also be equal to. We know that because of this half equal sign, this line under here. So to show that 1 can be one of my answers for X, I color it in. So the shading shows you the possible answers. We don't shade unless it's equal. There we go. Okay, so that's the difference. When we have a line under the symbol, we color it in. When there's no line, we leave it open and unshaded. And you guys are very smart. I'm sure you can guess what the other graphs will look like. If my numbers get bigger on the right side of the graph and they get smaller on the left, which direction do you think we will shade for less than?
Left.
To the left. Very good. So, right. Now we have X is less than 1. So our graph will again look very similar. We're going to label our number line with that number 1. We will circle the tick mark that represents number 1. We'll shade to the left. And do we shade in our circle or not?
No.
No. Why not?
It's open.
Because it's not equal to.
Because it's not equal to 1. X is less than 1. It's only a number that is less than 1, and 1 is not less than 1. And what will be the final difference for this last symbol, less than or equal to?
You shade the circle
You just shade the circle in.
and color to the left.
Yes, 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 yes. So we have our 1, we color in our circle, and we shade to the left.
It's the open shut.
Yes. So there's our little guide, our little answer key to help us as we try solving some inequalities. Leave that up for just a moment for anyone that needs it. And I do want to say as well, if anyone who is either here today or watching this video, if you would like a copy of this, I'm happy to make one. Just holler at me after class or come find me and let me know. I'll be happy to do that.
I went through my daughter's school stuff that she had at home. Wrapping paper. Packed away.
And we're going to do some examples. So let me retitle my page. Where else? One. This is page 2 of our notes. So let's start with something really simple. Let's do n plus 3 is greater than 12. Now, I want to remind everyone, you will solve this the exact same way you solve an equation. Just pretend this is an equal sign while you're solving it. We don't even need to worry about that until the very end. So, how would I solve this?
You subtract
Minus
3.
3.
Good, let's subtract 3, and then we're done.
12.
Simple one-step equation. So what is 12 minus 3?
9.
9. So we bring down our n, we bring down, instead of an equal, a greater than sign, 9. N is greater than 9. Okay, so now we have solved our first inequality. Not so bad. Let's graph it. So once you have the answer to an inequality, we are going to start by just drawing that same number line shape. And a lot of times what you'll see is an actual number line where all of the numbers will be listed out. But for our purposes, we're going to just label the answer. And we're going to say that we know there's other numbers there. It just takes a lot of time to write them all. So the first thing we do is we put the number that is our answer over the top of our tick mark, our little dash. What should we do after that? How do I graph this?
Circle.
Yes, let's circle that tick mark.
Leave it open.
Leave it open.
And shade to the right.
And shade to the right. Very, very nice. Another great trick for remembering which direction to shade is I like to just redraw the symbol over here. And I like to draw a line. It becomes an arrow. That arrow is going to point in the direction you should shade. So just another little trick to help out. I know that helps me a lot. So hopefully it helps you. Let's look at something more complicated. What if I took, for example, let's do one of our do now problems, but let's turn it into an inequality. And here's where I'm going to introduce you to a special thing about inequalities that I did not tell you about in algebra or in pre-algebra. This is a new thing. So, let me find one. Actually, I don't want to use a do now problem. I want to use, okay, let's do negative 2x minus 4 is greater than 16. Now, if you are currently thinking, I know how to solve inequalities, this is boring, I'm going to zone out. Okay, stay with me because this part I did not teach you last term. Now, if you were with Dave, maybe he did. I don't know. We'll see. I bet he did because it's Dave. So, let's start by assuming we know how to do this. How are we going to start solving this? What can we do first?
Add 4.
Let's add 4. Yeah, add 4 to both sides. Okay, my 4s will cancel. And what happens next?
Right now,
Bring everything down. I still have negative 2x greater than 20. Okay, now here is where things get special. What would we do next here?
divide.
Divide. What are we dividing by?
-2. -2 on both
Negative
sides.
2. So here's the fancy step. Anytime we have an inequality and the x or the n or whatever the variable is, if it starts off with a negative number on it, like this, and we end up dividing by a negative or multiplying by a negative, changing the sign of the variable, we have to do something here. And I'll show you. We divided by negative 2. Those cancel. And then I'm going to bring everything down. I have x, and then 20 divided by negative 2 is negative 10. But my symbol is going to change now.
Yeah, flip it.
We're going to flip it.
Oh, Lord.
Oh,
Because now your alligator mouth got to open up to the bigger number.
That's right.
Yeah.
So if we are saying that 20 is, or negative 2x is greater than 20, we're talking about negative x being greater than something. If I want to talk about positive x, that's going to be less than
Yeah,
instead.
it makes
Because
sense.
we're flipping the sign of the variable, we got to flip the sign of the sign. So instead of greater than, it becomes less than. Oh, wow, that's crazy.
I'm gonna have to make a note. Flip.
We're going to make a note. So
Flip it.
make this real big and bold in your notes.
Flip your sign. Flip your
Yes,
It makes sense, really.
right. When the variable changes from negative to positive or positive to negative, so I'm going to say when the variable changes signs. And in parentheses, I'll say dividing or multiplying by a negative number. So when the variable changes signs, the sign flips. So flip your symbol. I'll call it a symbol instead of a sign because I think that is going to get confusing if I call too many things the same name. So we switch from greater than to less than in this case. So if I start with greater than, it will become less than. If I start with less than, it will become greater than. If it has an or equal to on the bottom, that stays. You don't need to change that. You just change the direction that it's facing. That's all we do. So now that we have flipped our sign, we found our answer. We're just going to graph it like normal. This is the only new thing. So I will draw my number line. Oh, plus and minus there just to remind me. Now, what do I do to graph x is less than negative 10?
You put the 10 on the line,
Negative 10 on the line.
circle it,
Circle it.
and you shade to the left.
Shade to the left. Good. Good, good, good. All right.
Okay, I'm true. Okay, but it's open because
Because it's not equal to. So those rules will stay the same. The only thing that's different is when you divide by a negative number or multiply a negative number and your variable sign changes, then we flip the symbol. And this is the first one I've shown you. It's going to feel uncomfortable. We're going to do a bunch more and it will feel so easy at some point. It will. It will. Okay. Any other questions about that?
Dave drilled this.
I bet. I bet. I usually wait until Algebra 1 to teach it because, gosh, learning this is enough already, I think.
Yeah.
But,
Yeah.
you know, now we're doing it again.
No,
So,
okay,
good stuff.
I need the refresher. I'll tell you that.
Right.
I don't know why I kept having an issue with that. I did that.
I'm going to give you another one. Can I move this? All right, let's try 10 minus n divided by 3 is greater than or equal to negative 2.
You want to add 2 to both sides?
Okay, so let's be careful. We are going to do something with 10. But let's look at the symbol to the left of 10. Is there a symbol?
No.
No, so is it positive or negative?
Positive.
Positive. How do I get rid of positive 10? I subtract 10. I see your eyes probably looking right at this minus sign and you
I
think,
will.
oh yeah, let's add 10 because it's
I will.
negative. Remember the sign goes with the number this way of it. So 10 has no sign beside it. It's positive 10. Next, we have minus n over 3. So the 10 is positive, and to get rid of it, we're going to subtract 10.
Okay.
So let's subtract 10 from both sides. Now be careful, we're doing a negative minus 10. Negative 2 minus 10.
That's positive now.
Is it?
Negative 12.
Negative.
Oh, a negative 12. If we were multiplying, it would become positive. But we are taking negative 2, that's our starting point, and then I take 10 away from that.
Negative.
We're going even further negative to negative 12.
Negative 12.
Yeah.
Okay.
So negative 12 here, and we'll bring everything else down. What gets brought down over here?
The n over 3. Negative n.
Negative n over 3, because we're subtracting n over 3. It's 10 minus n over 3, so we keep that minus sign because it's to the left of it.
Can we keep the symbol too?
We keep the symbol. We haven't changed the sign of our n yet. So now I have negative n over 3 is greater than or equal to negative 12.
So are we going to, we're timesing 3 to negative 12.
Yes, yes. So let's get that n by itself. Let's get rid of 3. Sure. Times 3.
Please cancel.
3's cancel. And what does that leave me with?
Negative
over here?
36.
Negative n.
Yeah.
Good. Is greater than or equal to negative
Negative
36.
36.
Correct. Perfect. Okay. Now, what do I do next? Quick hold, actually.
It's assigned to open up to the negative 36.
Okay, so let's see. We are going to end up flipping the sign, but we don't want to just flip the sign and keep these numbers the same. We only flip the sign or flip the symbol if the sign of our variable changes. Right? What do we need to do here? We don't want to know what is greater than negative n. I want to know positive n. What do I do?
Do you add?
Add?
1.
I don't know.
Well, I guess you could. Rhonda, you're onto something. I've actually never tried to do it this way, but technically you could do this, I think. Yeah. So watch this. I want to show you it. This might be a solution to not even having to flip the symbol because it'll happen automatically this way. Let's do this. Let's add in to both sides. Okay. What happens over here?
Cancels.
It cancels. So I'm going to write 0. Okay. And then greater than or equal to. Now I have negative 36 plus n. But I want my n on one side and my number on the other. So how do I get 36 over there? Or negative 36?
You take that. Don't you add it to the 0?
Yes.
Okay.
Yes. Okay, so let's add 36 to both sides. Plus 36. Plus 36.
That's 4 steps.
And yes, it is. It is a lot of steps. Now, this is the long way of doing it, but seeing it this way might help you understand why we're flipping the sign. So now, if I were to rewrite everything, I have 36 is greater than or equal to
N.
n. Now, if I were to look at this, we want to rearrange this so that n comes first. I don't want to read 36 is greater than n. That doesn't tell me anything. I want to know how are my numbers related to n. So we're going to kind of flip-flop this whole thing. Now notice, and I'm going to refer to this in kind of silly terms because it's what makes sense to me and maybe it'll make sense to you, but let's pretend this is our alligator, okay? He's got sharp
It's
teeth.
another platform.
He is eating 36. When I flip this around and make n come first and 36 come second, that alligator better still be eating 36. So the sign has to flip. It needs to be pointing the same way. N is less than 36, or less than or equal to. N is less than or equal to 36. Do we see what happened there?
Mm-hmm.
Now, this was the long way of doing it, but it is still correct. If we wanted to, we could start from this step where I had negative n is greater than or equal to negative 36. And I could say to myself, well, I could divide both sides by negative 1, right?
Oh, I said, yeah.
Let's do that. If I divide both sides by negative 1, this becomes positive n. My sign changed, so I flip my symbol, and negative 36 divided by negative 1 is positive 36. So look, I get the same answer both ways. But notice that in both scenarios, our sign does flip. See that? We started with greater than, we ended with less than. Okay. You know, it's the thing. I a very roundabout way of me showing this to you. Do we have questions? We'll do some more examples.
I think so.
Okay, let's do some more. I'll leave this up for a minute. I see people still copying it down. Okay, let's also graph this. So if my answer is n is less than or equal to 36, here's my number line, here's my tick mark, my plus, my minus.
36.
We're gonna put 36 on that number line. We're gonna make a circle and we are gonna color it in this time. Why?
Because it's equal greater than or equal to.
Yes. Now it's not just less than, it's less than or equal. So 36 is a possible answer. So we're gonna color it. In what direction?
Straight to the left.
To the left. Good. Very, very good.
Everything you eat is gonna be on the table to the left.
What'd you say?
I said anything the alligator eats is gonna be to the left.
Yes. Good stuff. All right. After this, we'll do one more together and then I'm gonna give you guys a break. Right. Okay, guys, we're gonna go ahead and flip the page. We're gonna do one more and then I'll give you a break.
Let's put notes continue.
Yes. Notes continue.
Some part of it.
Page 3.
Yeah, because I gotta go work straight after class.
One more together. Let's now let's do. Go easy on you. Negative 3n is less than 24.
Just pay what?
How do I solve this?
Page 3.
What am I gonna do here?
Divide by -3.
Divide by negative 3. Now I'm starting off with negative 3n. So keep in mind, we're starting with a negative variable. If I divide by a negative, what happens to that variable? It becomes a positive. So over here, negative 3 divided by negative 3, that cancels out. We're going to have 1n left. So we can just write n. And since it changed from negative to positive, what do we need to also change?
Signs.
Our sign / our symbol. So instead of less than, it's greater than. 24 divided by negative 3. Negative 7. Oh, negative what is it?
What?
8.
Negative 8.
Yes, it's negative 8.
I didn't get it on time.
Negative 8.
You got there.
All right. So we have n is greater than negative 8. We're done. Okay, let's graph it. So,
8 on the center. Then her 8.
perfect. Negative 8 on my tick mark.
Yeah, and we shade to the right. Circle your line.
Circle it.
And shade to the right.
Shade it. Good. Number it, circle it, shade it. 3 steps. Not too bad. All right, guys. I think that's enough abuse. I'm gonna give you a break. We're gonna pause this recording. It is 1:51. Let's come back. Let's see.
Oh, yeah.
Yeah, let's say no later than 2:10. That gives you almost 20 minutes.
Okay.
So I'll pause it here. You guys just enjoy a break. Do whatever you need to do. And when you come back, I'll have worksheets ready for you. Okay, we are back from our break. That's just where we left off. And I just passed out this worksheet. If you are, I'm going to say this for the people watching the video, not here. If you're not here, this is what the worksheet looks like. Let's see, we have 8 problems on this worksheet. And I would like for you guys to work through these. What I am also going to do is I would like for you to finish all 8 and your exit ticket today. I know, we're cutting it short, huh? Our exit ticket today is going to be 2 of these problems, but I'm not going to tell you which 2. Okay? I want you to do all 8 of them, and I'm going to skim over them, but there are going to be 2 of them that I will take for credit. That will be a surprise. So I do want you to finish all 8. Now feel free to ask questions as we go through these. Now some of them you'll notice in your notes, we actually already did. For example, number 2, we just did that one. So I'm not technically making you redo all of them. If you peek back at what we did, some of these we already solved. So I would like for you guys to look through this, do your best to solve them all. And again, if you have any questions after working through, let me know. I'm happy to help. And this will be our exit ticket. So that's what I'm going to do. I'm going to write the exit ticket on here. This is your day 3 exit ticket. So I would love, and it would be super helpful, if before you turn this in, you also write day 3 exit ticket on there. That way it doesn't get mixed up with other assignments. It just makes my life a little bit easier, and it's just one extra step for you. So again, and I wrote this on the instructions, remember, if you are multiplying or dividing by a negative number, causing your variable's sign to change, don't forget to flip. I wrote sign here, but flip the symbol, slash the sign. That is kind of the only new thing here. And with that being your exit ticket, I'm going to go ahead and end this recording. That's going to be our video today.